Binomial distribution. Suppose that trial is repeated n times. There's an experiment which you're doing and that experiment is repeated n times, and occurrence of any event is called the success, and in case if that event doesn't occur, that is called failure. The probability that that event occurs is given by P, and the probability that it doesn't occur, that is failure, is given by 1 minus P, which we call as Q. Since these are the only two events, so either event will occur or event will not occur, so these two probabilities should sum up to 1. Note that both of these trials are independent. Both of these trials, as what I mean to say is that all of these trials, they are independent. That is, when you are having one experiment, okay, then you repeat that experiment, then you again repeat that experiment, then you again repeat that experiment. So all of these experiments, they are independent of each other. Okay. But having said that, the probability of success and failure, which is P and Q, they are same in every trial. Okay. So for example, you toss a coin. Now tossing a coin, and your event is that head should appear. So the success is that head should appear. Failure is tail is appearing. Probability of head appearing is 1 by 2. Probability of tail appearing is 1 by 2. And they both sum up to 1. Note that all of these events, that is probability of head occurring in from one event to from one experiment to the other experiment to the other experiment, they're all independent. And these probabilities, that is head occurring in the first event or tail occurring in these events, they're all constant in every experiment. Okay. Now by compound probability theorem, let me write this. By compound probability theorem, what you can write is that probability that first X trials are success, probability that first X trials are success, and how many remaining trials are there? N minus X. There are N, experiment is repeated N times. So first trial is X trial, remaining trials are N minus X trials. For the N minus X trials, they are failures. Okay, since these are independent, all of these events, so once you suppose you toss a coin, you get head, and that head has a probability P. You go on repeating this, and you go on repeating this till X trials, and the first X trials, they are these first X trials, they are the success, and for the remaining N minus X trials, that is failure is happening. Okay, N minus X trials, failure is happening. So this P has occurred for X times, so it is P to the power X, and this is Q to the power N minus X. The number of successes in N trials may be X equals to 0 to N. So I'll just write it down for you guys. These number of successes could be anything. It could be just one, okay, and the remaining could be N minus 1 for the failure. So number of successes in N trials could be anything from x equals to 0, 1 to n, this thing. Now let me name this as 1. Okay, so well, this is a very particular kind of um, um, what do you call that? It is of this probability which we have just found out. This is a very particular nature in which the first trials, they're all success, and then the remaining trials are all failures. But it may or may not happen like this. It could be the first trial is success, and then the second trial is failure, and then other two trials are success, then the other trial is failure, and so on and so forth. So you want any of these x trials out of these chosen n trials to be success. Okay, so what do you want is that these x trials can be chosen out of n trials how they could be chosen in NCX mutually exclusive ways. Okay, it could be chosen in these mutually exclusive ways. So by the theorem of total probability, by total probability theorem, so the probability of success in these n trials, in these independent n trials, the probability of success is x px. It is given by ncx. You're choosing these x trials from these n trials into p to the power x, q to the power n minus x, where x could be from 0, 1, and so on to n. So you guys got this? What I did is this. So the first trials are all x, and the remaining trials is n minus x. This is very particular nature. You want any of these trials, any of these n trials could be success, and any of these n minus n and any of these n trials could be failure, and that is given by this. Okay, you're choosing x trials from these n trials. You're not arranging them in a particular order. Is that okay? Now you can find out for probability, for various, you can find out the probability distribution for various values of x. Okay, you can write the probability distribution. When x is 0, then this becomes nc0 p to the power 0 q to the power n minus 0. When x is equal to 1, this becomes nc1 p to the power 1 q to the power n minus 1, and so on to when this is n, when x is equal to n, so this becomes ncn p to the power n q to the power n minus n. Is that right? This is called the probability distribution of number of successes. Of number of successes obtained. Okay, this probability distribution of number of successes obtained, this is called binomial distribution. Okay, because of the features which we have just defined above, that all of these are independent trials, they have the probability of success and failure is same. Okay, now also note that the probabilities, they're the various terms in the binomial expansion. These probabilities which you have found out, nc0 p to the power 0 q to the power n minus 0, nc1 p to the power n p to the power 1 q to the power n minus 1, and so on. All of these, they are the terms in the binomial expansion of this q plus p to the power n. So this is if you'll expand it, you'll be getting this NC1, sorry, q to the power n minus 1 p NC2 q to the power n minus 2 p2, and so on to NCn q to the power 0 p to the power n. So you guys could see here all of these probabilities. Okay, all of these probabilities, these are the different terms of the binomial expansion of q plus p to the power n. Okay, one more thing I just want to tell you that the sum of the probabilities in a binomial probability distribution is 1. Okay, as you guys could see here, q plus p to the power n. What is q plus p? What is q? 1 minus p. What is p? Is just p. So 1 minus p plus p is 1. So it is 1 to the power n, which is equal to 1. Okay. So binomial distribution, you could see here, it contains two independent events. One is p or q. Okay. And sorry, it contains two independent constants. One is n. Fine. So n is the number of trials, and p or q, these are the parameters of p or q. These are called the parameters of the binomial distribution. These are called the parameters of binomial distribution. Binomial distribution. And in general, you might be given in your textbooks like this, that if x is a binomial variate, if x is a binomial variate, okay, with parameters n and p, we write x, which is distributed as binomial distribution, okay, with these parameters n and p. See, once you have defined p, you have already defined q also, which is just 1 minus p. Or you can also write x, which is distributed binomially with parameters this. Or you can also write like this, which is p x, which is distributed. Now this is binomial distribution, which should be NCx p to the power x q to the power n minus x.